Late one night in 1942, London, Winston Churchill was taking a bath. This was no ordinary moment of relaxation, for floating in the water before him was a slab of a dull, grayish, translucent new material. Churchill turned to his scientific advisor and boomed, "So, you're saying this can win us the Battle of the Atlantic?" Without a word, the advisor drew a pistol and fired directly at the slab of ice in the tub. The bullet didn't shatter it. Instead, it ricocheted off, narrowly missing a general standing nearby. Churchill grinned. This wasn't science fiction. This was the birth of one of the most insane top-secret projects of World War II, Project Habakkuk. The British Empire was preparing to build a floating fortress 600 meters long, displacing 2 million tons, made entirely of ice. Why did the world's most powerful navy resort to building ships out of ice? What desperation and scientific madness lay behind it? Today, we will spend 50 minutes deconstructing the life and death of the ice aircraft carrier. Is less than #2 number. To understand Project Habakkuk, we must return to the Atlantic in 1942. Britain was choking. Admiral Donutz's U-boat wolf packs were at their peak. Every month, hundreds of Allied supply ships were sent to the bottom of the ocean. On the naval charts of the time, there was a terrifying zone pilots called the Mid-Atlantic Gap. This was a 500-mile stretch of ocean beyond the reach of land-based fighters and bombers. Once a convoy entered this black hole, it lost all air cover. German U-boats waited here, hunting convoys like fish in a barrel. The Allies needed aircraft carriers, and lots of them. The problem? Steel. By 1942, steel production had hit a wall. Building a standard carrier took tens of thousands of tons of steel and years of labor. Every scrap of British steel was already going into tanks and shells. Enter Geoffrey Pyke, a genius, a madman, and a strategic visionary. Pyke wasn't a shipbuilder. He was an unconventional thinker who asked a simple question. If we have no steel, what is the one thing the ocean has in abundance? Water. Or rather, ice. Pyke submitted a 200-page memo to Churchill. He argued that while ice is brittle on a massive scale, it is a natural armor. More importantly, repairing an ice ship wouldn't require a shipyard, just cooling pipes and more water. He named the project Habakkuk after the biblical prophet. "Behold, for I will work a work in your days which ye will not believe, though it be told you." This was the beginning of the madness. The madness of Project Habakkuk rested on a single, impossible material: Pykrete. Initially, Geoffrey Pyke tried using pure ice, but ice has a fatal flaw: it's brittle. If a German torpedo hit a block of pure ice, the entire structure would shatter like glass due to the sheer kinetic energy. Furthermore, ice flows under its own weight, a phenomenon known as plastic deformation. A ship made of pure ice would eventually sag and lose its shape just by sitting in the ocean. Pyke turned to two researchers at the Polytechnic Institute of Brooklyn, Hermann Mark and Max Perutz. They discovered that if you mixed 14% wood pulp with 86% water and froze the mixture, the resulting substance was a mechanical miracle. Why sawdust? On a molecular level, the wood fibers act like the rebar in reinforced concrete. They create a complex network that disrupts the cleavage planes of the ice crystals. When a force is applied, the wood fibers absorb the energy and redistribute it, preventing cracks from propagating. The properties of Pykrete were staggering. Crushing strength, over 1,100 pounds per square inch. Resistance to heat, because wood pulp is a natural insulator, Pykrete melts infinitely slower than normal ice. Workability? It could be machined like wood or cast like concrete into massive blocks. To test this, the team didn't just stay in the lab. They built a 1,000-ton prototype in Jasper National Park, Canada. They called it the Ark. It was a giant block of ice 60 feet long, kept frozen by a single 1-horsepower motor. It survived an entire Canadian summer without melting. This wasn't just a theory anymore. They were looking at a material that was as tough as concrete but floated like wood. The most famous and dangerous moment in the history of Habakkuk occurred in August 1943 at the Quebec Conference. High-ranking Allied leaders, including Mountbatten, King, and Arnold, were gathered to discuss the invasion of Europe. Lord Mountbatten, a firm believer in Pyke's genius, decided to demonstrate Pykrete's power in the most dramatic way possible. He walked into the meeting room with 2 blocks. One was ordinary ice, the other was Pykrete. He invited the strongest man in the room to chop the ice with an axe. The ordinary ice shattered instantly. Then, the man swung at the Pykrete. The axe bounced off, vibrating so hard it nearly dislocated the man's shoulder. But Mountbatten wasn't finished. He drew his service revolver. "Gentlemen," he said, "watch this." He fired a shot at the ordinary ice. It disintegrated. Then he fired at the Pykrete. The bullet didn't just stop, it ricocheted. It whizzed past the ear of Admiral Ernest King, nearly killing the commander-in-chief of the U.S. fleet, and embedded itself in the wall. The room went silent. Amidst the smell of gunpowder, the Allied High Command realized they weren't looking at a joke. They were looking at a fortress that could potentially shrug off a German torpedo as if it were a pebble. When we speak of aircraft carriers today, we think of the USS Gerald R. Ford, a massive vessel spanning 337 meters with a displacement of 100,000 tons. But the proposed HMS Habakkuk made the modern supercarrier look like a toy boat in a bathtub. The blueprints finalized by Jeffrey Pike and his team of naval architects called for a structure 600 meters 2,000 feet long and 90 meters 300 feet wide. The hull thickness was not measured in inches but in feet, specifically 40 feet, 12 meters of solid Pykrete armor. To put this in perspective, the hull alone would have been thick enough to shrug off multiple direct hits from the largest torpedoes in the German Kriegsmarine's arsenal, without the structural integrity being compromised in the slightest. The total displacement of this frozen titan was calculated at 2.2 million tons. To understand the scale of this insanity, consider that the RMS Titanic displaced about 52,000 tons. HMS Habakkuk was designed to be 40 times heavier than the Titanic. It was essentially a floating island, a man-made iceberg designed to be invincible. But a 2 million ton block of ice has one major problem: thermodynamics. Even in the cold North Atlantic, a block of ice this size would eventually melt due to the friction of the water and the ambient air temperature. To solve this, the British engineers designed a cooling system that was more complex than any industrial refrigerator ever built on land. Inside the 4 0-foot thick walls of Pykrete, they planned to install a labyrinthine network of thousands of miles of steel pipes. These pipes would circulate a high-pressure refrigerant liquid ammonia at sub-zero temperatures. This would ensure that the core of the ship remained frozen solid, effectively making the ship a self-healing organism. If a German torpedo managed to blow a hole in the hull, the crew wouldn't need a dry dock for repairs. They would simply pump fresh seawater into the gap and turn up the refrigeration. The ocean itself would provide the repair material. The ship would literally freeze its own wounds shut. How do you move 2.2 million tons of ice through a stormy ocean? You cannot use a traditional internal engine room because the heat generated by massive steam turbines would melt the ship from the inside out. The engineering solution was as radical as the material itself. The Habakkuk was designed to be powered by 26 external electric propulsion pods mounted on the sides of the hull. Each of these pods was essentially a self-contained motor and propeller unit. By placing the engines on the outside, the heat dissipated directly into the cold seawater, protecting the Pykrete hull. The power required to drive this beast was estimated at 33,000 horsepower. Even with this massive output, the Habakkuk wouldn't be winning any races. Its top speed was projected to be a mere 6 knots, 7 miles per hour. But Jeffrey Pike argued that speed was irrelevant. The Habakkuk wasn't meant to be a cruiser. It was meant to be a permanent, unsinkable airfield in the middle of the Atlantic Gap. It was a piece of territory that the British could move, albeit very slowly, to wherever the U-boats were most active. The interior of the Habakkuk was designed to house a crew of 1,500 sailors and airmen. Because the Pykrete was such an excellent insulator, the living quarters wouldn't be freezing. The engineers planned to line the interior cavities with layers of cork and wood, creating a pressurized, heated environment for the crew. The flight deck was designed to be large enough to handle not just small fighters like the Supermarine Spitfire, but also heavy twin-engine bombers like the Vickers Wellington. This was the true strategic value, providing land-based bomber support in the middle of the ocean. The deck would be covered with a layer of traditional tarmac or wood to prevent the planes from sliding on the ice surface. However, as the design progressed, the costs began to spiral out of control. To build just one Habakkuk, the British realized they would need 1. 300,000 tons of wood pulp. 2. 25,000 tons of fiberboard insulation. 3. 10,000 tons of steel for the cooling pipes. 4. A specialized construction crew of 5,000 men. Suddenly, the cheap ice ship was starting to cost as much as an entire fleet of traditional steel carriers. The sheer amount of steel required just for the cooling pipes and the internal reinforcement was almost as much as a small conventional carrier. This was the first crack in the dream of the ice ship. By late 1943, as the blueprints for HMS Habakkuk reached their peak complexity, the world outside the ice office was changing rapidly. The very problem Habakkuk was designed to solve, the Atlantic Gap, was being attacked from other, more conventional directions. Two major technological breakthroughs began to render the ice carrier obsolete before the first block of Pykrete was even cast for the full-scale version. First was the development of the drop tank. British and American engineers perfected external jettisonable fuel tanks for fighters like the P-51 Mustang and the B-24 Liberator. Suddenly, land-based aircraft could fly hundreds of miles further than they could in 1942. The gap was shrinking not because of a floating island, but because of better plumbing in airplane wings. Second was the mass production of escort carriers, CVEs, often called jeep carriers. These were smaller, cheaper carriers built on merchant ship hulls. While they weren't invincible like Habakkuk, they were fast to build and available in large numbers. The U.S. shipyards were churning them out at a rate that the British Admiralty could barely believe. But the final nail in the coffin was the steel paradox. Jeffrey Pike's original selling point was that ice was cheap and steel was scarce. However, as the engineering team added more refrigeration pipes, reinforced bulkheads, and massive engine pods, the steel requirement for HMS Habakkuk ballooned to over 19,000 tons. For context, 19,000 tons of steel was enough to build a traditional, fast-moving Colossus-class light fleet carrier. The military leadership faced a brutal choice. Do we spend our precious steel on a 2-million-ton island that moves at 6 knots and might melt? Or do we build a proven fast attack carrier? In December 1943, a secret meeting was held in Washington, D.C. The American generals, who were initially impressed by the pistol shot demonstration in Quebec, had grown skeptical. Admiral Ernest King, the man who nearly lost an ear to the ricocheting bullet, was particularly vocal. He argued that the logistics of providing wood pulp, hundreds of thousands of tons of it, would clog the North American rail system. "We are fighting a war of movement," King reportedly said. "Habakkuk is a monument to a war of static defense that no longer exists." Even Lord Mountbatten, the project's greatest champion, began to distance himself as the costs reached an estimated $100,001,942 The project was officially downgraded from top priority to experimental. The dream of a frozen fleet was beginning to thaw. While the grand project was cancelled in early 1944, the prototype in Canada, the Ark, remained. This was the 1,000-ton scale model built in Jasper National Park. When the engineers turned off the refrigeration motors and walked away, everyone expected the block of ice to disappear within a few weeks of the Canadian summer. But they had underestimated the power of Pykrete. The wood pulp insulation was so effective that the massive block of ice refused to die. It sat in the lake, a gray, hulking ghost of a secret war. One summer passed, then another. It took 3 full summers for the prototype of HMS Habakkuk to finally melt into the waters of Patricia Lake. Divers today can still find the remains of the wooden forms and the cooling pipes at the bottom of the lake, a silent tombstone for the largest ship that never was. Project Habakkuk is often laughed at as a mad scientist footnote of World War II, but it represents something profound about the human spirit under pressure. It was the ultimate out-of-the-box thinking. It laid the groundwork for modern materials science, the study of composite materials. The idea of reinforcing a brittle matrix ice with a strong fiber wood is exactly how we build modern carbon fiber wings and Kevlar vests today. Alan Turing broke the codes, the women of Bletchley Park processed the data, and Jeffrey Pike tried to freeze the ocean. They all shared the same belief, that against the raw, industrial power of the Nazi war machine, the only weapon that truly mattered was unconventional intelligence.